Hi, I'm Andre Duran.
And I'm Caitlin Clark,
And
we're both in 11th grade.
yeah, and we're working on a device.
This is a project for plant growth lovers that just can't keep them growing. Maybe you're not at home or you can't remember to water your plants, but either way, this project is for you.
So we used an Arduino and connected it with a solenoid valve and a soil moisture sensor to water your plants for you. And it's very simple. Once the soil gets so dry, the moisture sensor will say, hey, water the plants. And then the solenoid valve will open, letting the water run down.
This system is unique in the sense that it uses soil moisture value readings instead of the traditional irrigation system that is based on a timer. But this is better because it also allows for other variables such as rain levels. This is our code for the Arduino. It includes both the information for the soil moisture to get it to work, as well as Bluetooth code, so it connects to an app that we have. Down here, I used an if command. Is it to show that if the soil moisture readings get between these levels, that's when you turn the water on, which is high on the solenoid pin, and off is 375. And through testing, figured out the different values of the soil moisture readings for. Here's a close-up look at our Arduino setup. So here we have our soil moisture sensor reader, which is what will sit in the soil and determine if it's dry or not. And then this is our Bluetooth module, which we use to connect to the app to send signals back and forth to change the if value. And then this is a humidity sensor that we're adding because we're also working in the process of adding other functions that this one doesn't work right now, but it will in the future, just for air humidity as well, just to monitor more things, as well as we're thinking about adding a light sensor as well. This is our DLI port that we use to place this in the normally off, when that's why it's normally off, and then this will connect to the solenoid valve and turn it on. And then this is always on to just make sure the Arduino is always on. And this will plug into the wall for power.
This is our first 3D model design. As you can see here, you can see how we put everything together. Here's the top pipe, the bottom pipe, and then we also have just the water stand by itself, just the soil bins and everything, and behind Caitlin, you can see everything in all of its glory. So it really helps having the on-shape design to go off of, because you get a digital look of what you're trying to build. And here's the box design. We finally added what holds all the electronics to the full design this year. And you can see we made the little rivets in here so that it would all connect together without any glue. And it's pretty cool having just taking the next step. And I had to learn how to use the laser cutter to cut out all these pieces and put it all together.
So this is our prototype that we built based off of the CAD model. This is the box that holds all the electronics that Andre laser printed.
And we also have our solenoid valve and our soil moisture sensor. All of the electronics are hidden away in the box, and you just put it in here, but whenever it's dry, the water will run through. So now we're going to do a demonstration of the thing actually working. And so here's the moisture sensor. I take it out. It turns on because there's no moisture in the air. I put it in. It turns on.
I made an app that would connect via Bluetooth to the Arduino that would allow people to be able to change the different values for different plants for the soil moisture settings. For example, like you'd want a cactus, the water to turn on at a lower value than for something like a fern. Okay, so I have my app pulled up on this phone, and I used MIT App Inventor to build my app. And so this is the home page, and you can connect different buttons. Like, for example, I'm going to be going to the water control screen. Click on, come on. There it goes. And this is how you change the water control values. So this one to change the number I have in, and this will change the value for the if command, the first one for the on one. And then this one will change the number for the off command. And then you can just go back to the home page.
Here's my portfolio on the project. As you can see, a year and a half ago, it didn't look good at all. And you can just see how it's been changing over time. Here's the old code, and here's fritzing, which is what we would use. We'd use this chip if we ever manufactured this. And here's last year's tech fair. As you can see, it still didn't look good. And then we made the CAD model, and that's basically when COVID hit and we had to go home and stop working on the project for a little bit. So then here's the start of this year. We made it modular so you could add or remove more and more pieces to it. And yeah.
During this whole experience of the project, I learned a lot about not only coding through the Arduino, but also just learning about the Arduino and learning how to wire it and the different pins and the different functions, as well as I gained a lot of experience in building an app and app development that I didn't have before at all. I went from nothing to be able to design a whole app, which was really cool.
Me too. I've learned a lot. I've learned about Adobe Illustrator. That's how we laser cut all our parts. And then I've learned a lot about 3D modeling and Onshape, where we designed the whole project off of. And this project's been a lot of fun for the both of us. And the fun part is, the easiest part of the project is building the whole thing, but the hardest part is getting it to work.
This type of technology would revolutionize agriculture and would really be useful in the real world.
And if we were to bring it to the real world, we would make it a consumer product for everyday people like me and you that they could use in their house or in their personal garden.
With the fritzing chip that we already developed, that we would use that to be able to, we'd purchase one for real and fabricate it. And if we were to improve upon our design, we'd use that to condense everything smaller. And so people would actually want to have it in their homes.
While we are marketing this as a consumer product, this could be used everywhere worldwide as just agriculture in general.
Thank you for your time, for listening to us. We've worked really hard and are really passionate about this project, so it means a lot.
For the past year and a half, we've been working on this project, and because of COVID, it's been really hard to get a product that we're happy with, and right now we're pretty happy. There's still some things that we would change and some things we'd make a little bit better, but it is what it is, and we're very excited to show you guys. Thanks for the opportunity of the Tech Fair this year. It means a lot to the both of us.
Again, thank you.
This is an awesome opportunity for us students to put on our college resume, anything. It means a lot to me and Caitlin for you guys to do this. And yeah, again, thank you. Bye.
Bye.